All right, Algebra 3, Lesson 39. What this is going to cover in your book, starting on page 277, is radian measure of angles, which we've already talked about how to do that in forms of linear equations. Basically, you're going to learn about double intercept form and standard form. Double intercept form will probably be the only new one. You're already familiar with y-intercept form. Okay, so let's talk about for a second question number 1. Man, that was really hopping there. All right, Jack watched a bug crawl through an arc of 6 degrees along the rim of his melon, which was cut in half. If the radius of the melon was 4 inches, how far did the bug crawl? What this is actually dealing with is arc length. How many of you remember what arc length is in terms of a formula? Length of an arc, yes. What's the formula? What's that? It is something m over 360. 2, no. Okay, so this is how to remember when it's 2 pi r, because arc length uses the circumference of a circle, okay? All right, that would be my circumference of a circle. Circumference of a circle is 2 pi r, except we don't want the whole length around the whole thing. We want a fraction of it. So that's where my measure over 360 comes in. Does that make more sense? So if we've got a melon, okay, and we've got an arc of 6 degrees, okay, and it says that this whole thing was cut in half, so, oh my gosh, this is going to make me sick. Okay. The radius of the melon is 4 inches, so what we're interested in is just that. And probably on the video it doesn't even give you any indication that the screen is bouncing up and down. Yeah, it probably goes off the computer, and the computer's not shaking, so. All right. So 2 pi r. So for us, the radius is what? The radius is 4, so we're using 2 pi 4. And then we have 6 over 360. And you can reduce that fraction, right? That's giving us, what, 8 pi? And why is this different than that? 4 inches. Okay. All right, so I'm getting 8 pi times, what, 1 over 60, right? All right, so here we're just going to go ahead and take the decimal form of this. What do you get? So that's going to be 8 pi over 60, correct? Okay, what's 8 pi divided by 60? And Marissa, can you get the stuff out of the 5 folder? No, just give me the decimal, the straight decimal. 0.42, right? Okay, 0.42 inches. So that's how far the bug crawled. Why Jack is watching a bug crawl less than half an inch and trying to figure out how far the bug crawled, right? I don't know. Jack's got a lot of time on his hands. Okay, next question up. This one is one you're going to want to know how to do because this is a little less easy. Okay, so we've got sine squared. Okay, notice that it doesn't give me degrees; it gives me radians. 11 pi over 6 plus let's see, cosine squared 2 pi over 3. Okay, minus tangent squared. And we got 5 pi over 3. Okay, my recommendation to you is convert all radians to degrees. Okay, so how do I convert radians to degrees? It's honestly a lot easier than converting from degrees to radians. We don't know. Okay, we substitute 180 in for pi. So this is 11 times 180 divided by 6. So I can rewrite that as sine squared what? What's 11 times 180 and then divide by 6? Should be 330 degrees. If you got something other than 330, your calculator might be in radian mode. Plus cosine squared. What is 2 times 180 divided by 3? Well, that's probably, what, 120? Because 2 times 180 is 360. 360 divided by 3 is probably 120. I could be wrong. 120 degrees. Okay. All right, minus tangent squared. 5 times 180 divided by 3. I don't know that one off the top of my head. 300. All right, so we got this into things that are a little easier to work with, right? All right, now I'm going to do some coordinate grids for these three things. Okay, see where these things wind up at. 330 degrees is going to bring me all the way around here. Okay, what is my reference angle at 330 degrees? 30 degrees, because I'm 30 degrees shy of making it all the way around. Okay, which means I know that this is negative 1, okay, 2, and radical 3 goes right there, correct? Okay, 120 degrees. Okay, 120 degrees is going this way, right? And I am what? What's my reference angle? 60 degrees, because I'm 60 degrees shy of 180. Okay, so I have negative 1, radical 3, and 2 right there, correct? Okay, 300 degrees, coming all the way around. What is my reference angle here? 60 degrees. Good job. Okay, so we got a 1 there, a negative radical 3 here, and a 2 there. Okay? All right. What is my ratio in the sine format from this first spot here? I'm going to drag this down here a little bit, give myself some more space. Okay. All right, so sine, I'm getting negative 1 over 2, right? All right, now this is where that squared comes in, because I'm going to square that answer. Okay? We'll come back to it here in a second. Let's come on to the next one. All right, cosine is negative 1 over 2, right? Adjacent over hypotenuse, negative 1 over 2 squared. Okay? And then on this one, opposite over adjacent, negative radical 3 over 1 squared, right? Okay? Now, I'm going to go ahead and bring down my operations. There's a negative there. There's a plus here, correct? Okay? All right, let's give ourselves... All right, negative 1 squared is what? 1. All right, what's 2 squared? 4. Okay? What's negative 1 squared? What's 2 squared? 4. Okay? What's negative radical 3 squared? 3. Okay? And it'll just be over 1, right? But if I want to combine all this, I'm going to have to change 3 over 1 to 12 over 4. Okay? Does that make sense? So I got 1 plus 1/4 plus 1/4 minus 12/4. So I've got, what, 2/4 minus 12/4? So it would be what? Negative 10/4. Let's make sure of the, or negative 5/2. Yep. Okay? Or you could get negative 2.5. Okay, something like that. But does this, if we follow this process step by step, can we do this? First step, get your degrees. Okay? Plot your coordinates. Okay? Get your ratios. Square your ratios. Okay? Get common denominators. Add, subtract, all that kind of good stuff. Okay? In this case, could I check my answer by plugging all of this in the calculator? Okay, but I've got to make sure that I'm doing sine squared, which I don't know. I don't know that you can do that actually. So you may not be able to actually do these just straight up in your calculator. All right. Number 3 is exactly like number 1. How many of us are familiar enough with arc length that we need to do another one of those? Do you want to do another one? Ralph watched a bug crawl through an arc at 24 degrees along the rim of the melon, which was cut in half. If the radius of the melon was 4 inches, how far did the bug? It doesn't even matter that the melon is cut in half, by the way. No.
Because it's just a circle.
Right, because you're still basing it upon. It doesn't change the fact that you're still basing it upon a whole circle. Okay, so let's just make sure that we're writing this up correctly. We know that we're going to get 2 pi r measure over 360. Okay, so we've got 2 times pi. What's the radius on that question?
4.
Okay, what's the measure this time? 24 over 360. You should be able to do all that in your calculator. You should get 1.68 inches. Yep, he got a little bit further this time. He went 24 degrees. All right. Let's come down to number 4. It says use the midpoint formula to find the equation of the perpendicular bisector of the line segment whose endpoints are -3, 2, -1, 6. And he wants to write the equation in double intercept form. So I'm going to introduce you guys to double intercept form today. We've already done questions like this. The first thing that we're going to do, let's see, as I work out, let's see, number 4. We've got -3, 2, -1, 6. Okay. And we'll go ahead and get this figured out. Okay. So it's the equation of the perpendicular bisector. So the first thing that we do, slope, perpendicular. Yep, perpendicular. So y2 minus y1 over x2 minus x1. Okay? Okay, that's giving me 4, -1 plus 3. Okay, giving me 2, which means perpendicular now. Okay, -1/2. Okay, bisector. Okay, how do I apply the bisector? What formula do I use? Okay, this was slope, midpoint. Okay, midpoint. x1 plus x2, right? Or, -3 plus -1 divided by 2. 2 plus 6 divided by 2. Okay, what's -3 plus -1? -2 divided by 2. -4 divided by 2. -2. Okay, 2 plus 6 divided by 2. Did I mess something up? Okay. All right. Now, step 3. Okay, point slope. Okay, so y minus what? Y minus 4 equals? -1/2 x minus -2. Okay? All right. So we have y minus 4 equals -1/2 x. Okay, what's -1/2 times 2? -1 plus 4. Y equals -1/2 x plus 3. Okay, so that's the equation in slope-intercept form. Okay, y equals -1/2 x plus 3. Double intercept form, okay, is a little different. Okay, in double intercept form, we want x and y on the same side. So that would give me 1/2 x plus y equals 3, right? Yes? All right. Double intercept form wants x over a number plus or minus y over a number equals 1. 1 being the dominant part of it. All right? So how can I get this to equal 1? No. Divide by 3 on both sides. Because what's 3 divided by 3? 1. So as long as I divide by the solution on both sides, I should always get 1. All right, what's 1/2 divided by 3? Well, that would be the same as 1/2 divided by, or multiplied by 1/3, right? 1/6, or x over 6 plus y over 3. No, plus, okay? It's x over 6 plus y over 3 equals 1. That is the double intercept form. That if this was a negative here for some reason, okay? All right, does that make sense? Do we understand how to get the double intercept form of an equation? Solve, get your y-intercept, right? And if you give me the y-intercept, I will, if on a test it says solve for the double intercept, ask me and I'll tell you, does it have to be double intercept or can it be y-intercept? Okay, and I'll tell you. Questions there? All right. All right, the next question. This one, it says use the point slope form to find the general form of the equation. General form of an equation is, you're not unfamiliar with it. You may just not remember what it's called. AX plus BY plus C equals 0. That's the general form of an equation where everything's on one side. Okay? They start off by giving you, -6, 4, and a slope of -3, right? They want the general form of the equation. So you're using that y minus, in this case 4, equals -3x minus -6, right? Yes? Okay, y minus 4 equals -3x. You got -3 times +6, so -18. Okay, add 4. Am I going too fast for it? I feel like this is old information, so I'm just kind of going to scoot through it. Okay, y equals -3x, minus 14? All right, so first thing first, it wants the general form of the equation, right? Okay, so the general form of the equation means I got to move everything to the left-hand side. So that's giving me 3x plus y plus 14 equals 0. Do we get that? Okay. The double intercept form of the equation. Okay, we want just x and y on the left. So that would be 3x plus y equals -14. What do I need to do to get that into double intercept form? Divide by -14. Okay. All right, so we know that's going to equal 1. We know we're going to get y over -14. Okay, but now we have this 3 over -14. Well, does that reduce? Okay, the problem is that it has to be x over. It can't be something x over. Okay, that's my situation. So let's see. We are looking at this, I got to remember, as x over -14 over 3. Okay, so that's what it is. Okay, x has to be on top. So you divide by the 3. Well, it would be if y was in that same situation. Although, if we've solved for y first, we'll never be in that situation because y will always have a coefficient of 1. Okay? So this is the double intercept form. This is the general form. Here we've got the slope intercept form. Questions about that? Okay. All right, number 6. Use the midpoint formula to find the equation of the perpendicular bisector, and it wants the equation in general form. Do you feel like you need to do that? It should just be like, it's really, it's kind of like number 4. Do we want to do number 6 just to see it again? I'm getting nobody shaking their head yes. What about number 7? Are you guys good with the double intercept in the general form? Okay, all right. If you don't feel like you need any more help with it, I'll stop right there. Let's see, is there, let me look in your assignment. Is there anything in your assignment that deals with some of these? What questions did you guys get? So pick a question from your homework. I'll go ahead and I'll work it out on the board. Or if you see a question similar to what's in your review for your test and you see something like it in your homework, you might want to ask about it. Like question 21, I think, is in your review. But I don't know if you're going to struggle with that or not. It's not in your homework. Okay, well, I'll cover something on just in the homework problems that looks like what's on your review. I'm going to give you about 5 seconds to pick something out. If you give me nothing, I'm just going to hit stop on the video and okay, all right, I'm going to hit stop then.